So we ended up last time in mass measurements. Now we go to measuring volume. Okay. Measuring volume, specifically the use of volumetric glassware, is very important in analytical chemistry, because you are obliged, to have precise measurement of the volume. Sorry, this is volume. So the unit is liter. For smaller volumes, we have the ml, and microliter could also be used. And these are the volumetric glassware. So we have here the volumetric pipette. This is a graduated pipette. Later, you will know later the difference between the two. Then we have the burette, and of course the volumetric size of different sizes. We have here as small as 5 ml volumetric flask. We're using that in chromatographic analysis. So this is 250 ml. Okay. Okay, what is the effect of temperature on volume measurements? So here, it is stated that the volume occupied by a given mass of the liquid varies with temperature. And of course, during calibration of every volumetric glassware, you must also take note on the temperature and humidity inside the lab. Okay, so we have here volumetric flask and the graduated cylinder. This one is the bulb one is the volumetric pipette. Okay, so volumetric pipettes accurately deliver a fixed volume. A small volume remains at the tip. Diri o may ara na siya upon aspirating the liquids, no? Tapos din transfer ni mo na sa flask or whatever container nga you wanted to be transferred. May ara din siya class, may bilin yun na siya sa small volume of the liquid, no, in the tip. So hindi nyo na siya pag i-force na i-push yung pagwa because the pipettes are so calibrated nga may ara na siya sa gamay na volume na siya nagkakabiling sa tip. Okay, so these are measuring pipettes. These are marked at different volumes. They are less accurate than the volumetric pipette. That's why during standardization of your solutions, during preparation of your standard curves in spectrophotometric analysis, and also in chromatographic analysis, you should use this one, not this one. Hindi na siya pwede. Because they are less accurate than the volumetric pipettes. So each volume may ara na siya specific pipette. So the example, this is 10 ml. May ara man siya 1 ml nga volumetric pipette, 2 ml, until 100 ml. Sa amon, we still have the 100 ml volumetric pipettes. So take note that in measuring pipettes, may gradation na siya, no? So makita mo na siya. 0, 1, 2, no, until 10 ml. But in the volumetric pipette, it's only this one is 10 ml. So malabot, gana di siya ho, 10 ml. Wala na siya sa markings na 9 ml, no, 2 ml, wala. Exactly, at the mark, it's 10 ml. And this one is microsyringe pipettes. Usually, this is used in chromatographic analysis ng sa mga high-performance liquid chrom, gas chrom, amo ni siyang ginagamit for injecting the sample into the machine. Okay, they deliver microliter volumes. They are commonly used to enter the samples into a gas chromatograph or a liquid chromatograph. So, ang volumes ni may ara isang 10 microliter, may ara 20 microliter. But now, commonly used is 10 microliter. Okay, this one are automatic pipettes na tawag sa ila. So it can deliver 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this one is a multi-channel digital displacement pipettes. And this one is a single channel. No? Usually, ginagamit na siya sa micro lab. But then, pwede mo siya magamit sa analytical chem lab. But usually, sa mga molecular bio, no? Because, we also have his microwell plates. Diri ni siya di ba kay micropipette? So, microwell plates ang iyan na siya gina-dispense. So, diri ni siya. So, if it's 10 channel digital displacement. So usually 10 man na siya ang microwells. The plastic tips ini siya are disposable. Kita na kamo ni class?
Wala pa, miss.
Kita na kamo. Wala pa kamo.
Sa mga scene.
Okay, you later can see it when we go to instrumentation because we all have this in the lab, in our lab. Sa virtual laboratory, makita nyo na the analyst in charge of the test will be using also this one. Especially we're using this in the determination of chloramphenicol in seafood products like crab meat. No? Kaya gina-require sang export gina-require some importing countries for our product like crab meat to be checked for presence or traces of chloramphenicol. It's an antibiotic. Okay. So we also have error limits for single channel air displacement pipettes in the table. So we have here the different volumes, no? Different kinds of pipettes, no? So may 1 ml pipette, no? May ara man siya 2 ml. We refer this one as single channel. Why? Kaya isa lang siya ang iyang tip. This one are multi-channel digital displacement pipette. So, ibutang mo lang na kung pila ang volume. I-dispense mo like 0.5 ml or 0.05 liter. 0.05 ml. So, tanan-tanan ni siya class ng 14 tips would also aspirate. Would also take in 0.05 ml. Tanan-tanan sila. Depende sa adjustment. Now, this one is pwede siya mag 0.45 ml because if this is a 1 ml single channel pipette, adjustable. So, pwede mo siya ma-adjust 0.1, 0.2, 0.3 up to maximum of 1 ml. But then, there are single channel pipettes na fix ang volume. Ang halimbawa, yun na is the same as this one. No, fix ang volume. You could not take in 0.5 or 0.9, no, because it is fixed. This one is fixed at 10 ml. So there are pipettes na automatic pipette tawag na nila, which is also fixed at a certain volume, like this one. Okay. So with here, um, 1 ml, may 2 ml man na fixed, no? So and so forth. And these are the maximum error, and these are the relative errors. So take note of this. No, I will also be discussing this one when we are in the applications of statistics in analytical CHEM. Okay. Now we go to burettes. Some other labs, they uses measuring pipettes to titrate, but that's not the appropriate glassware no, to use. It's the burette. So there's a 25 ml burette. Mm-mm. Pwede man na siya. Okay, so going back, no, there is a 25 ml burette and there is also a 50 ml burette. No? It is marked in 0.1 ml increments. So 0.1 ang iyan na siya nga tawag na sa Ilonggo. ang basta increments, iya bala nga lakang-lakan na tawag. Hindi ko kaano sa Ilonggo ka translate. Okay, so you interpolate 0.01 ml due to about plus minus 0.02 ml. Okay, after that, you take for every sample, you should have at least three trials or three replicates for you also to apply your statistical tools. Now, okay, so how do you read a burette? Usually, for what do you call it? Sa English siya bala bansay, no? For those who have not yet developed the skills of reading burettes, you could use may black and white na cardboard paper for you to check as easily if you are already getting the correct reading na. And you should avoid parallax error. So you should read at the eye level. So this is the meniscus illuminator. And then how do you titrate properly? So during your lab activity, you should also be observant on how the analyst actually does the titration. Now, for you to get familiar with the techniques. And you will also have virtual laboratories in this, no? Especially when you are into acid-base titration. So one analyst also in our lab will show you how from standardization of your standardization of your titrant as against the primary standard, no? Di ba na-discuss na up to titration, no? Determination of whatever, if you will determine alkalinity or if you'll do neutralization reactions, no? Depende sa lab activity. So place the flask on a white background. Dili dapat may bond paper kamo sa dalom kung hindi pa kamo bala adept sa color changes because you will be also having indicators. Next, place the burette tip on the neck of the flask while you swirl, no, the Erlenmeyer flask. But now it's easier because we already have the magnetic stirrer. Hindi hindi na kinala na manual na siya. So So you could have magnetic bars, ibutang na di siya sa solution, sa flask, then place it in the magnetic stirrer, and then you can do the titration na lang. No? Hindi na kinadal nga ikaw pa mas-swirl. No, because if you could just imagine, if you have like 30 samples, tapos ikaw lang isa swirl mo manually kapoy-kapoy na. 30 samples times 3 trials pagget, so that's 90, di ba? Unlike if you have a magnetic stirrer, mas sapos lang. Okay, so your first lab activity this afternoon will be calibrations, no? Calibrations of laboratory glassware. So you will calibrate the pipette and also burettes and also a volumetric flask. Okay. So pipette is a high precision laboratory instrument that requires proper maintenance on a regular basis. And there are two general types. We have the volumetric or transfer pipette. At wala kagina ang the bulb pipette. You remember the first the first slide na may pipette. So this is designed to deliver to may TD na siya na naka-etch, etch na mark na siya na TD sa iya nga sa iya ng tip sa babaw. So it's sorry. Okay, so it is designed to deliver a fixed volume of liquid. So wala gradation, no? So it's fixed volume of liquid, be it be 1 ml or 2 ml or 10 ml, fixed gina siya at the volume yung gina-states ng glassware. It consists of a cylindrical bulb joined at both ends to the narrower glass tubing. So amo ni siyang gina-refer class sir. Ano yan? Ano ni siya? Volumetric pipette. So may bulb siya sa dogabusong sa tunga. Okay. Calibration mark is etched around the upper suction tube. Lower delivery tube is drawn out to a fine tip. So this is used for accurate measurements of aliquots of non-viscous samples, filtrates, controls, and standard solutions. So again, this is very important in standardizing solutions, in delivering accurate volume of aliquots, especially in dilutions. Next, the other one, we have the graduated or measuring pipettes. Graduated, so meaning may ara sa mga markings, no? May mga 1 ml, 0.5, 0.5, 0.1, mga ano na siya. So plain narrow tube drawn out to a tip, graduated uniformly along its length. Two types which are calibrated for delivery are more pipette, calibrated between two marks on the stem, and the serological pipette. Okay, so ang serological pipette has graduation marks down on the tip and blown out to deliver the entire volume. So hindi siya dapat na may bilin siya sa tip, no? Unlike the other one, yung mga amo ni siya nga pipette, sorry, no? Ang may ara siya volume nga nag-remain ang sa tip, no? Ang transfer or volumetric pipette. But then the measuring pipette, especially the serological pipette, okay, ang iyang graduation marks down on the tip and blown out to deliver the entire volume of the pipette if edge ring or double rings are evident near the mouth of the pipette. So, may ara na di siya sample na rin. Nakakalayo. Lang yung class sa taon ko lang. I hear. So, alam, kung double ring, amo ni siya. Tapos, may edge mark na siya ng sa dalom. Ano yung edge mark na double ring? Ano yun? So after draining, ato contain pipette. Ato kagina yung class ang volumetric pipette is to deliver. Diba? Ato lang daw may bulb sa tunga. It's to deliver. This one, ang mga serological pipette or Morse pipette is to contain. No? After draining, to contain pipette, the residual liquid on the tip should be blown out with pressure from a pipette valve. Ano? So, di ba may marking siya? Dapat i-blow, ano ganun siya, i-pag-on ganun siya. To contain pipettes should be blown out. To deliver pipettes and volumetric pipettes should not be blown out. So, you know the difference, ha? Okay, so mabalik na to, ane. Balik lang tanda karon. Okay. Next, how and where and how do you store pipettes, no, for pipetting accuracy? So proper storage, very important factor in maintaining an accurate pipetting result. So if you store it upright, it prevents any liquids from corroding the internal workings of your pipette. And also very important is store your pipettes away from windows, heating sources, or in an environment with low moisture. So grabe no, may requirements man ang pipettes on storage condition. So ways to stop pipetting errors from ruining your experiment. Without accurate pipetting, experiments would not be reproducible. What do you mean by reproducible? Anybody? Let me see. Bethel Joy, okay. What does reproducible mean, no, sa Analchem? Or sa GenChem na lang, di ba may mga lab man kamo before? Ano na siya nga statistical tool related? Ang term na reproducible. Anybody? May graded recitation, kamo ba lang? Yes, Neil. Okay, that's good enough. So experiments will be reproducible. So this is related to what statistical parameter? Precision, diba? Reproducibility. Stock solutions would be inaccurate. Why? Why do you think na ang stock solutions would be inaccurate if your pipetting is also not accurate? Stock solution. So what is affected? Jane Flores. Jane Flores, are you in? Anybody?
Hello, Miss.
Yes. Who's this?
Try
Is?
lang, Miss. Jude Gonzalez.
June Gonzalez, okay.
Gonzalez.
Gonzaga, sorry. Okay.
Ang ginanamin, Miss, if ang first mo balangagin measure, Miss, ng sala, then ang preceding or ang succeeding mga ipang measure, Miss, is sala man, Miss. Lupa mo na.
Yes. That's okay. Okay, so we are here pertaining to stock solutions. Di ba ang stock solution, yun na dapat exact din na ang concentration or accurate concentration no kay stock solutions. So if you are correct, if the pipetting is inaccurate, di ba kagina naghambal to nga pipettes are used no in pipetting ng mga alikot. So if sala, syempre ang concentrations niyo in the preparation of your stock solution would be also erroneous sa sala man. So okay. Next, assays would have large assays would have large errors that comparing them would be meaningless. So assays, 'di ba? Assays mga ultimate analysis no kung ano na ang ga-contain ang mga samples, ano nga mga substance. Okay, know how pipette work. Position instrument as they may be, but the accuracy of your micropipettes depends on you because you are the one operating it, di ba? So analysts should develop skills. Now we go to automatic pipettes. So we have here the as you can, if you can recall, we have the single displacement and the multi-channel displacement pipettes. Now we go to air displacement pipette, automatic pipette. Ni siya class it works a bit like a syringe, amo ni siya, oh. Except that there is air-filled cushion between the piston and the sample. So here is the sample, and this is the airspace. No, and this is the piston. And this is your disposable pipette tip. Nagkaguro, makuha na lang ako sa pipette. Kabudlay ma-explain, yung makita na lang yung class sa makuha na lang ko. And then again, stop. Paano rin siya more than ikaw? Guys, makita nyo? Paano rin siya mag-enlarge to ako nun? Kita niya, hindi.
Yes, miss.
Taon,
Yes,
miss.
Taon,
miss.
miss.
Taon,
Ara.
miss.
Ara, miss.
Kita niya. Amo mo siyang multi-channel pipette. Alaunan. Amo ni siyang pipette tips. Teka, putaan ko. Ano siya? Single channel. Kita niyo? Yan. Tapos sa mo na yung pipette tip. So, ano siya without the tip? Tapos with the tip, ano siya? Tapos, ano siya variable ni siya ang volume niya because may isang adjuster no? Pwede mo siya ma-adjust to what volume na gusto mo. But there are pipettes na wala na ni siya, fixed na siya to 1 ml. Tapos, amo ni siya ang bulutangan sa pipette tips. Ay, sorry. Ibalik ko. Ang iyang canister. Tapos, amo ni siya ang microwave. I-open ko. Alright, so na amo ni siyang microwells. So pwede na din siya ang 0.1 microliter. So ano niyo na din siya So from the tip po, nito siya ang suction with ang liquid. Dito. So pwede na siya di siya kaso na kung i-aspirate nyo ang liquid, then you can transfer in here. Tapos, ang multi-channel, damo-damo ni siya nga tips at the same time dire makasulod. Then you can also at the same time transfer. So at a time, pwede kagad at a time, pwede siya man 2, 4, 6, 8, 10, 12. So pwede siya. Dasig lang. Rather than isa-isahon. Balik na ta sa lecture. Expectations. Temperature and pressure affects the volume of the air cushion here. Affects the volume of the air cushion, which also affects pipetting accuracy ang airspace ni siya. So this is one limitation. Another one, volatile solvents can evaporate in the air cushion, which lead to an inaccurate and lower dispense volume than what is displayed in the pipette nga. Kaya may ara siya effect ang presence ng airspace to the solvents. No? Kaya pwede siya ma-evaporate ang solvent kag makadto to sa airspace. So the volume that you will dispense is not exactly as it is displayed in the pipette sa adjustment bala. So hindi siya exactly na because of in the presence of the airspace. So ini siya nga kind of pipette is appropriate only to non-volatile solvents. Okay, sa mga tubig, sa mga what else, basta sa mga other liquids. Next, another limitation. The barrel of the air displacement pipette is vulnerable to contamination. This one, sa may piston and the shelf, no? Especially if you are dealing with corrosives or biohazardous materials. So this prone sa contamination and this kind of pipette. Next. Okay. So this is the anatomy of the pipette. May are this and disposable tip and this is the shelf. Amo ni siya ang tip holder. Next, this is the tip ejector. Kung gusto mo na nga i-eject ni ang pipette tip, you just push this one. Mahulog na siya ang pipette tip if you're already done. And this one is the push bottom, no? And large volume adjustment knob. So if you push this one, pag may tip na di siya may pipette tip, ma-aspirate na ang liquid, dere, masulod na ang liquid. Then how to how to dispense, i-push mo naman balik, no, para magwa ang liquid kung diin mo man na siya gusto i-transfer. Okay? Now, the other one is air displacement. Another kind is the positive displacement pipettes. So this one is the piston. Ari ka gina ang piston for the air displacement. But for the positive displacement, this one. So there is also here sa positive displacement, sa air displacement na siya. So this one is the unprotected airspace, no, sa regular air displacement pipette, which is prone to vapor contamination and also aerosol contamination. But in the positive displacement pipette, we have the protected airspace. So there is no aerosol contamination or no vapor contamination. So mas mayo ang positive displacement pipette. Okay. Positive displacement pipettes also work like a syringe, but they don't have an air cushion, unlike the air displacement pipette. More accurate, this one, the positive displacement pipette, this one is more accurate for pipetting volatile solvents because there is no place for the solvent to evaporate, unlike in the air displacement pipette. Okay? So this is the parts of these are the parts of the positive displacement pipette. Meron siya, of course, ang piston. Then may volumeter display, push button for and also for ejection of the capillary and piston. Then this one. May ara siya da yun sa serial number. Okay, so this is a closer sorry, dali lang yan. Okay, we have here the regular air displacement pipette. Okay, so we have your pipette tip, the airspace, no, here. Then you have here your filter, but despite having a filter, prone siya gapon sa contamination, no? Sa aerosol contamination, especially sa mga this one, biohazardous material and corrosives. As against the positive displacement pipette na instead of the aerosol, wala siya yan, no aerosol, then there is a protected airspace in here. And also, kita niyo ni siya ang pointed na part, no? Wala siya yung pointed na part ang air displacement pipette. So this is capillary. Okay, the lack of air cushion decreases the chance of contamination in the positive displacement pipette when pipetting corrosives and biohazardous material. This makes positive displacement pipettes more suitable to working with reagents. So, Mira, nakamutip, no, especially if in charge ka mo sa purchasing sa mga equipment and lab supplies. Ano ang dapat nga i-purchase depende sa usage also. Okay, today there is a pipette for virtually every requirement like aqueous solutions. Aqueous solutions, okay na to sa air displacement pipette kay it's cheaper and it can also serve the purpose. But for dense, viscous solutions, kinahanglan ang positive displacement pipette. And also for DNA sequencing, so here are the different samples. Okay, the type of analysis you are performing, the physical properties of the liquid and volume range of the pipette will determine which pipette and tip you should use. So depende sa kind of sample. Diba for radioactive corrosive samples, much better ang positive displacement pipette. And so with biological samples. And so with viscous sample, for aqueous samples, okay na ang air displacement. Okay, so we have here 3 things to remember for air displacement pipettes recommended for aqueous samples and for general laboratory work. This is much cheaper than the positive displacement pipette. So always have a cushion of air or dead volume between the pipette piston and the liquid sample. So you have in here the air cushion. The piston is a permanent part of the pipette, this one. Now we go to the positive displacement pipettes. 3 things to remember recommended for problem samples like viscous, dense, volatile, radioactive, and corrosives. Direct contact of the piston with the sample because it has no air cushion. Disposable piston. Kay amo ni siya ang replaceable ang piston for this kind of pipette. So how do air displacement pipettes work? No, ang single channel lang tanay. So this is the volumeter. So first, set the volume. The required volume is set. The piston moves to the appropriate position. But again, be reminded that there are also fixed volume automatic pipettes. So in here, we are discussing pipettes which can be adjustable. Okay, so when the push button is pressed, the piston moves down to let the air out. The volume of the air displaced is equal to the volume of the liquid aspirated. So, okay, so kung i-push niya siya, class, i-push niya siya, ang air siya magwa. So here. Then, pag push, ano mo naman siya, ibalik mo naman siya, ang ma-displace mo air would be replaced by the solution or your liquid na you are working with. Okay? So when the push button is pressed, the piston moves down to let the air out. This one, the volume of the air displaced is equal to the volume of the liquid aspirated. Next, what about the positive displacement pipettes? It also, pareha man gyapon ang principle, but only then it allows very viscous or high density samples such as mercury or toothpaste, pwede siya dire sa positive displacement pipette. Okay, so after that, you transfer your volume in the pipette tip to your container. So the push button is pressed prior to sample aspiration. The piston descends and expels a volume of air equal to the selected volume of the liquid. Now, as the push button is released, a partial vacuum is created, forcing the desired volume of liquid through the orifice into the tip. So, ara na siya. Then push mo siya, ang air na dispense. After that, then balik mo ang button, nagsulod na ang liquid sample, which is equal to the air that was driven out. Okay, after that, then dispense mo naman ang sample sa container. Then push mo naman liwat ang button. The air pressure increases inside the shaft and the compressed air pushes the liquid out of the tip. So nasulod na siya sa test tube or whatever container mo siya gimbutang. Okay? Same also principle with the positive displacement. Kaya ini siya is air. This one, the red one, is the positive displacement. Pareha lang din ang explanation. Okay. So to get reliable results, we must consider the different factors to improve pipetting. Like the physical properties of the liquid. So aqueous, pwede na itong ang air displacement pipette for viscous and volatile samples ang positive displacement pipettes. Most liquids are of the aqueous type, making air displacement pipettes the first choice. Positive displacement pipettes in very viscous or volatile liquids. Now, other lab apparatus, glasswares, and plasticwares. Okay, so you have here the film hood. This one. And we also have the laminar flow hood with a HEPA filter. Usually, this one, the laminar flow hood, usually this is used in micro laboratories. So there is a high efficiency particulate air filter, or we call it HEPA filter in this part. Okay, you already are familiar with this, no? Wash bottles. We have the squeeze type, and this one is the blow type. These are used for quantitative transfer of precipitates and solutions and for washing precipitates. Next, we have the filtering crucible. So A is the bush crucible, B, sintered glass crucible, and C, we have the porcelain filter crucibles are used for filtering non-gelatinous precipitates. Okay, so this is using filtering crucible in vacuum filtration. Nakakita na kamo class ang vacuum filtration setup? Wala pa? Class, nakakita na kamo?
Wala pa,
Miss.
Miss.
Oh, wala pa, Miss.
Wala, Miss.
Ay, kaloy. Kada mo pa sa wala din nakita. So anyway, we will be performing total suspended solids also in water as one of your laboratory activities, and we will be using vacuum filtration setup. So makita niyo makita niyo na iniga na introduce ko lang ang mga common nga apparatus and their setup, the introductory lang to your laboratory activities later. So the first one, this afternoon, we will be performing calibration of pipettes, volumetric glasswares, and burettes. Next, we have ashless filter papers. So, gamiton taman ni sa vacuum filtration ang iban. So there are different kinds of filter papers. If you've noticed, they are numbered. Number 42. This is what we're using in filtering liquids prior atomic absorption analysis, no, sa trace metals. So, and also this is suggested or appropriate for very fine precipitates like barium sulfate. No? Next, Wattman number 40, 8 mm for small or medium precipitate like silver chloride. And number 41 is for gelatinous or large crystals like ginagamit man ni siya sa soil analysis. Okay, so this is a properly folded filter paper. No? Sa hindi ordinary yung filter paper has this one because you are already applying this to methods, analytical methods. Okay, this provides a good seal in siya nga type of folding and prevents air bubbles from being drawn in. So may reason why we have to fold like this one. Suction from the weight of the water in the stem increases the filtration rate. Here part. Let the precipitate settle in the beaker before beginning that filtration process. Someone is class. Here techniques, no? Proper technique for transfer of precipitate. So decant the solution by pouring down the steering red. So yun, butang mo siya steering red, tapos amo na siya pag decant mo na sa solution. Then after decanting the mother liquor, add wash water to the precipitate and decant again 3 times. So here, amo ni siya ang technique on how to wash the precipitate. Several times, 2 to 3 times. Then wash the precipitate into the filter. Now this one, this rubber polishman is used to scrub the walls of the beaker and collect all the precipitate by washing. And this is how to ignite the crucible constantly. Okay, before adding the filter precipitate. So again, you you fold the filter paper over the precipitate, then drive off the moisture at low heat. But now we don't have any more Bunsen burners, right? So, there and then. Ano na mo ang ginagamit? Sa labs, we already have hot plates. Then we also have microwave ovens for rapid drying. And usually, ginagamit niya siya sa determination of metals, no? Prior atomic absorption analysis. So here, acid decomposition times are reduced from hours to minutes only. Kaya diba kung mag-digest ka, acid digestion ka sa sample, it would take 1 to 2 hours, sometimes 3 hours, no, prior sample prep na siya ha, sample preparation, prior reading it to an atomic absorption spectrophotometer. So instead of hours, no, it is only in minutes. And it mas less hazardous pa sa analysis. Okay, another advantage is lower black levels are achieved with reduced amounts of reagents. Next, we have the Keldal flasks. These are used for acid digestions. And these are tilted while heating to avoid losses from bumping. So, ginatilt na siya during heating. So, here 10, 30, 500 ml, mine's 250 ml. So, these are Keldal flasks. Next, go to calibrating volumetric glasswares. This will be your lab activity this afternoon. So for volumetric flask, weigh out a dry and clean volumetric flask. After that, fill it to the mark with boiled distilled water at room temperature. Why do we have to use boiled distilled water? To expel what gas? Anybody? Amigdaze. My question is, why do you think we have to boil the distilled water? Distilled na water na siya, i-boil pa siya, no? Nga at room temperature.
Miss?
Yes,
Nang water vapor, miss?
no. To expel what gas? What gas do you think is present? Starts with letter C. Ano nga?
Carbon dioxide, miss.
dioxide. Okay. After that, so fill into mark with boiled distilled water at room temperature. Then after that, measure the weight of the flask with the water and record the temperature of the water it contains, okay? Then this is your equation. Calculate the volume of the flask. So volume in ml is equal to weight of the filled flask, atong may water na bala, minus the weight of the empty flask in grams times the correction factor. May table na, I just give you the table. Correction factor times the weight of the filled flask minus in grams, okay, minus weight of the empty flask. So that's how to determine the how to calibrate volumetric flask. Tapos lang, no? Pero kung wala ka mo kabalo, mahambalambing ang calibration of volumetric flask, do ka budlay how. But when you see how it is done, tapos lang. So you have to do this 3 times. Now, go to pipettes. Same also, fill the pipette with boiled water, but before that, you should weigh it first. Then fill the pipette with boiled water that is at room temperature. Dry the tip with a tissue. And after that, let water flow away until the lowest part of the meniscus touches the mark. Let the tip of the pipette be held against the inner wall of the vessel at 45 degrees. Para lang din ano bala ang tanan nga tubig nga ara sa tip niya. Not necessarily tanan, depende sa pipette. If volumetric, mayara, gina siya mabilin. If to contain ng pipette, dapat i-blow na siya out. Next, collect contents in a pre-weighed weighing bottle. Dapat ang pre-weighed di siya weighed to constant weight, no? Repeat procedure 4 times and measure the temperature of the water, and then you have this equation to get the standard volume of the pipette. Okay? So, nakalibrate yun na ang pipette nyo after. Next, for volumetric flask, same also, same process. And for burettes also, para hala. So you fill the burette with boiled water that is at room temperature. Okay. Next, adjust the lowest part of the minisole so that it touches the 0 mark. Then remove all drops that cling to the inner wall of the burette using a filter paper. Dapat wala yun siya sang errors, no? So you have to remove all drops nga para siya sa inner wall sang burette. After that, ano niyo naman siya, transfer niyo naman siya, run off the contents into a pre-weighed bottle na constant weight until the volume is reached. Entire volume na transfer na. Then collect the last drop from the tip of the burette and you measure the weight of the liquid, no, na halin sa burette and also the temperature of the water. So repeat procedure for at least, di ba, 3 times. Pero ang kaginaya for pipettes, 4 times. So the more, the better. Next, calculate again using this formula equation. Okay. Now, tips for calibrating glasswares and also pipette. Weigh a clean, dry conical flask with a rubber stopper or a weighing bottle with a glass stopper or cap. Next, fill the pipette with distilled water. Ato bala kaginang na-discuss na. Okay. So, ang highlights na lang. Same also with the burette. Kada mo, pabilang atong electron. Okay, now we go to cleaning and marking of lab wares. Okay, these are grease pencil or wax pencils. These are used to mark glassware when doing experiments or lab activities. Okay. So these are tips for cleaning. You just read na lang, ang highlights na lang. For precision chemical testing, new glasswares, this is usually the common error. Okay, diba, ang notion is, bago mo na siyang glassware from the supplier, tinlo na siya. No, that's not the case. Now, precision chemical testing, for precision chemical testing, new glassware should be soaked for several hours in acid. Ang bago or unused glassware, dapat i-soak siya for several hours in acid containing either hydrochloric or nitric acid before proceeding with the regular washing procedure. Okay, so in this table, the properties of the common laboratory materials or in here. So we have here for porcelain, di ba ang porcelain crucible, no, our example. Maximum working temperature for porcelains is 1,100 degrees Celsius to 1,400 So which means na pwede gini siya for ignition, no? So you will be using furnace, di ba? Very hot temperature furnace. Next, sensitivity to thermal shock, good. And chemical inertness, excellent. Now for, what else? Ang common lang. Okay, polyethylene. Maximum working temperature is 115 degrees Celsius. Chemical inertness, this is not attacked by alkali solutions or hydrofluoric acid, but it can be uh, attacked by organic solvents like acetone and ethanol. So, okay, given the chemical inertness, more or less, you will now have an idea. If, example, ang imo chemical is acetone, will you place it sa polyethylene bottle? In the AK, it's already stated here, attacked by many organic solvents like acetone. So just be familiar with the characteristics. Now, here, wash labware as quickly as possible after use. If labware is not cleaned immediately, it may become impossible to remove any residue, no, after using. So these are the different labwares used in also in organic chemistry, no, analytical and organic chemistry. So we have here number 1, the evaporating dish. Number 2, the thin layer chromatography chamber. TLC means thin layer chromatography. Number 3 is the Buckner funnel. This is used in filtration also. Number 4, Hurst funnel. Number 5, we have the rubber sleeves for the funnel. And 6, we have here the clay tile. 7, vials for storage of reagents also or samples. Number 8, we have here your stir bars and spin vane. Amo ni siyang ginabutang sa magnetic stirrer nga pwede man siya nga during titration or when you are mixing your reagents. Mas lasig ni siya than the manual stirring. Number 9 is the drying tube. Next, this is just a review. No, I presume that you already have discussed this in your Gen Chem. So we have here number 1, your extension clamps with and without vinyl sleeves. Next, number 2, 3-fingered. Nga ang 3-fingered, okay, 1, 2, 3. So 1, 2, 3. So this is a 3-fingered clamp, no, with vinyl and fire-resistant sleeves. This one, fire-resistant sleeves. No? Next, number 3 is a iron ring, and 4, wireless or wire gauze. Number 1 here is the thick-walled rubber tubing, the black one. Now, this is used during filtration, vacuum filtration. Yan siyang black na rubber tubing. Number 2, of course, Bunsen burner. Number 3, wood blocks. And number 4 is your rubber tubing. Now, I know you already have heard microscale chemistry, no? Experiments using small quantities of chemicals and simple equipment. So advantages, reduced costs, reduced safety hazards, allow many experiments to be done quickly and sometimes outside the lab. Now, these are the glassware commonly used in microscale work. So number 1, we have here the drying tube. Number 2, this one is the Hickman head. Number 3, this is the water condenser you're familiar with already sa, di ba, sa distilling apparatus. Number 4 is the air condenser. Number 5 is the conical vial. This is also graduated. Next, number 6 is the Cleason adapter, and 7 spin vane, or could also be steering bar. Okay. So familiar ka mo ni tawag ni siya is the ground glass joints, no? Mayroon siya frosted appearance na daw matawag na. Hindi siya bala clear, the ka-opaque, no, opaque part of the glassware. Now this is the ground glass joints. Common joint sizes are 14/20. This one, the diameter is 14 and wala lang kayo. Okay, and 20 is the length. So maghambag ni class nga common joint size, maghambag ni nga joint size of 14/20. So which means that the internal diameter of the joint is 14 and the length here is 20. And this one is a female joint. The other one here down here is the male joint. Okay. So always take note that the first number, the 14 here, is the inner diameter. The second number is the length, no, this one, of the frosted part. Now, sometimes, especially after the experiment, budlayan ka mo ni magkuha o sa joints, budlayan ka mo nag-topic, nag-get siya mo, ano siya, na doon na-fix sa. So, what will you do? Okay, so here, it is best if ground glass joints are free of chemicals when pieces are connected, or else the compounds may undergo reactions that cause the joints to freeze together or become inseparable. Okay? So what do you do, no? Before anything else, no, before joining, pwede nyo na siya i-wipe sang CHEM wipes, and after that, butangan sang gamay nga grease. No, CHEM wipes, lint-free ni siya nga daw tissue paper, generally used in the lab. So you wipe the pieces that will be connected with CHEM wipes, and also pwede mo siya butangan using grease. Pero kung ari na na-lock na good siya, what will you do? Here, gently twist the two pieces apart from one another. Next, if that feels, gently tap the joint with a spatula. Here. Or other piece of equipment. If that fails, you try heating the joint in a water bath, no? Because heat may cause expansion of the outer joint, or sonicating the flask if a sonicator is available. Wala, makamukha kita, sonicator, no? Sige lang, mag-ara na kamo sa chromatography. We also have that. Ipakita naman kami. Okay, as a last resort, heat the joint briefly with a heat gun to separate the pieces. Okay, so these are, as I have said, extension clamps. This one is the 3-fingered. And this is how to correctly mounted extension clamp. So dapat naka-grip yun siya sa sa naka-grip yun siya properly, hindi siya pwede mag-lockout. Sorry, na-class askan, tutudlan. Okay, this is how to use the three-fingered clamps. Ara siya. Letter D, no? Holding a chromatography column. And letter C, holding a pipette column. And letter A, it's holding a flask. So, kinanlan ang three-fingered clamp in this situation. Now, the ring clamps or the iron rings are also used to hold separatory funnels and also to secure funnels when filtering or pouring liquids into narrow joints. Ang mga siyang uses sa ring clamps. And then we have the wire mesh or the wire gauze to serve as platform for supporting the flask also and also during heating. Then there is also a keck clamps, no? Or plastic clips used to secure connections between joints, but never use this when you are heating because it will cause the clamps to other clips to melt. Okay, so to prevent freeze, to prevent frozen joints, na ano na siya bala na hindi siya bala makuha ang joints because na-lock na siya during after experiment. Before using it, you should apply grease. Pwede man siya petroleum ester. We are using petroleum jelly, I mean, petroleum jelly. So, ginabutang na siya sa connections. Gamay lang gid kay basi makakos man siya contamination if damo. Okay? So, there. You will notice that after the experiment, hapos lang siya magkuha. Okay, so grease is also used whenever the joint may be in contact with a highly basic solution like sodium chloride, sodium hydroxide, no? Because basic solutions can form sodium silicates and etch glass. Grease can be applied with a syringe full of grease, syringe, or using a toothpick or a wood splint. Okay, but be careful not to use or apply too much grease or dirigation mo sa dalawang ibutang because it might also dissolve the grease and your solution can become contaminated. Okay, how do you clean this one? Sorry, these glasswares. So, pwede man siya, you can use 2 to 3 ml solvent to rinse residual organic compounds from the glassware. Pwede man siya, you can use acetone. No, because the solvation ability is not spent after few uses. No? Wash acetone. You can use acetone. After that, pwede mo man siya ma-reuse again. So the purpose of the acetone is to dissolve organic residue in a flask. But take note that not everything dissolves in acetone. For example, ionic salts, no? So you must just use water kada man. Then after that, glassware should be washed with soap and water at the bench. Okay, residual acetone will evaporate from the flask, but it is acceptable for small quantities of residual acetone to be washed down the drain. So this is waste management, no dilution. Okay, diba? The DNR now is also inspecting laboratories for their waste management. So, in the case of acids, pwede lang gid na siya nga i-neutralize, then dilute. But for toxic metals, especially if you have atomic absorption spectrophotometers, ginatago, gina siya ang waste sa storage. Then, you must find a waste treater para magkuha sa inyong mga chemical waste. But for acids, ordinary acids and bases, pwede lang gid siya neutralize anay before draining down the drain. Okay? And so with acetone. Okay. For cleaning of glassware, some uses dilute soap solutions. Others use biodegradable detergent called Alphonox, which is the industry standard. Then after that, rinse all glassware with a few ml of distilled water. Before my experience kami na we used the distilled water bala for battery use. Then we found out that ang amol nga phosphate analysis, halin sa blank, positive na siya na daan, pati ang sample has very high reading. So we were able to troubleshoot by also checking on the distilled water. Kay before we just buy commercially available, kaya barato lang na siya ang distilled water na for battery use. But then, we found out the grabe gali ang phosphate concentration. So we shifted to Wilkins na suwang. Okay? So after that, now rinse our glasswares with few ml of distilled water, then store wet glasswares in a locker atop paper towels to evaporate for the next use. Next, for quick drying, you can use oven, no, for a temperature less than 100 degrees Celsius. Pwede man siya for speedy drying kung gadali gid ka mo. Okay, so glassware that appears dry actually contains a thin film of water condensation on its surface. So when using reagents that react with water, this water layer needs to be removed. Kaya nga ang other reagents nga that will react with water sometimes creates violent reaction. So dapat wala na siya. So how to evaporate the water film? The glassware can be placed in 110 degrees Celsius oven overnight or at least for several hours. The glassware can also be evaporated using a heat gun or a process called flame drying. So we have two, oven drying and flame drying for drying glasswares. Next, storing samples. Okay, so when samples must be stored for a period of time, they are best stored upright in screw cap vials. This one. Use Teflon tape or parafilm. Wala makamuguro nakakita sang parafilm ay, no? Stretchy plastic film to create a better seal. So ang parafilm amo ni siya oh. Next, this one is Teflon tape. So what is best? use Teflon tape as much as possible. Okay, ang parafilm still evaporate over a period of weeks. Ma-evaporate siya pa ang mga samples, so pwede pa siya maka-escape. But for the Teflon tape, less ang permeability niya. So this is how to transfer solids. So you use a wide mouth funnel or a powder funnel. Grabe no, pag wala ka mukha ano siguro isang term ng powder funnel ay makabati. Okay, so what else? Okay, ang highlights na ng class some solid compounds like potassium hydroxide, dipotassium carbonate, or calcium chloride are sticky or hygroscopic, meaning they can readily absorb water from the air. And these reagents should be dispensed on, take note, glossy weighing paper. So, amon, ginagamit naman wax paper. That is a wax coating so that the sticky reagents more easily slide off its surface. So, this is again a lab technique. Okay? Transferring liquids with volume less than 5 ml, they can be poured directly into vessels. But sometimes you may need also, especially if the volume is higher, you may need also iron ring na nag-support sa funnel. Or this one, no? You support the funnel by your hand. Okay, so these are techniques. When determining the mass of a vessel on a balance, it's best not to include the mass of a cork ring, this one, or other support like beaker. Now, the ring might get wet, no, which can also have an influence on the true weight of your vessel. So these are pasture pipettes. So, used to transfer volumes of liquids less than 5 ml from one container to another. So may ara din siya class dropper na i-squeeze nyo na siya. And these are marked also. May ara siya gradation. Okay, so this is how to transfer using pasture pipette. You squeeze the rubber tip here. After that, you deliver the Hello, sir. Good morning. Ano, sir? Anong area? Sampan? Yes, oo. Tapos i-composite sample na lang da yun. Tapos you bring 1 kilo na lang to the lab. Ha. Ano lang, sir, bacterial profile, including Vibrio para hemolyticus. Kaya if positive, dara na lang ta ma-EMS. 155. Wala man na nagsaka. Daw 2 weeks ago, amo naman ang presyo. Oo. Na, how? 100 na ka mo. Nagkakuha sila sa mall 2 to 3 tons at 155. Si Britannia, si Abner. Oo. Wala ang problema. Tapos sila ni Bourbon. Oo, 150 sila yung galing. Oo. Okay, sir. Okay, sige, welcome. Okay, so balik naman today. Where are we now? Letter C. Now, delivering liquid from a pasture pipette. Amo ni siyang tsakto klasa. Ito nga. Incorrect. One is letter D. Incorrect delivering of reagent. The tip should not touch the sides of the flask. Okay, so are you familiar with the general guideline that 1 ml is equivalent to 20 drops? This does not always hold true for pasture pipettes and may be inconsistent between different pipettes. Depende sa ano na siya sa iyang tip, no? Kami other pipettes to dako ang iyang diameter, whereas ang pasture pipette gamay rin siya. So this general guideline is not true to every pipette. Okay, so again, going back to pipettes, when a high level of precision is needed and calibrated glass pipettes, specifically volumetric pipettes, can be used or graduated. Volumetric pipettes is one, have glass bulb at the top of the neck, and are capable of dispensing only one certain volume. So take note of that now, volumetric pipette. Graduated pipette, this one, or the more pipettes have markings that allow them to deliver many volumes. So these are graduated pipettes. The volume markings on ang graduated pipette indicate the delivered volume. So take note, may duwa siya ka-line o. Okay, the leftmost pipette has markings of every 0.1 ml, so this one. So, okay, but no intermediary pipettes marking, so it's less precise than the other two pipettes. So 0.1 lang siya class o na, wala na niya sa intermediate na lines. While the other two pipettes here differ in the markings on the bottom. So, ang diriya, 1 ang pinaka-last niya. This one is 9. Kita niyo? Can you see it? The lowest mark on the middle pipette is 1 ml, while the lowest on the rightmost is 0.9 ml. So, to deliver 1 ml with the middle pipette, this one, the liquid must be drained from the top na zero, up to the 1.00 ml mark. This one, up to the and the final inch of the liquid should be retained. So, hindi nyo na siya class pag doon na, diri o. Mag-ano na bala, maggamit na mo. So, it's only, from the top, from the zero, up from the 10 ml, 10 itong sa babaw mo, up, dali ka. It should be from the top, which is 0, up to this one, the last mark. So never also deliver this one, ang volume after the mark. Okay. So from the 0 ml to the 1 ml mark na dapat. And the final inch of this liquid should be retained. Now, what about in this one? So to deliver 1 ml, must be drained from the 0 mark up to the tip. So dapat i-blow out gina siya ang ano min ang bilin dire i-push out gad siya because this is still part of the volume na required to be delivered. Okay? So amo nang difference nila na duwa. Okay. Pipettes are calibrated to deliver or to contain TD or TC. Pipettes are marked with TC or TD to differentiate between these two kinds. So may ara siya marking on TD in fine trim. Okay, so this one to deliver pipettes, also take note may double wing siya sa babaw. Plus a TD fine trim. Now, after draining the to deliver pipette, the tip should be touched to the side of the flask to withdraw any clinging drops, and a small amount of residual liquid will remain in the tip. So, okay. Okay. So, the ones that is subject to calibration are the to deliver pipette. So going back on this one. So this is to deliver pipette and this one is to contain pipette. So after draining to contain pipette, this one to contain pipette, the residual liquid on the tip should be blown out with pressure from the ariyo, ang bilin na siyang liquid, the should be blown out. Okay. So you already know this one, no? How to use the pipette bulb. Then a summary of what we have discussed. Next, pouring hot liquids. So this is the technique. You know, we use here a hot hand protector. Have you seen this one? Or either you can also use beaker tongs or a paper towel. No. When dealing with hot liquids. Okay, same also. Okay, so next meeting, we will discuss methods and flammability. And also, since we are, how many slides pa? We're just like 10 slides pa. So then we'll discuss laboratory notebook. Be able also to answer your progress checks questions and submit it to me on Monday. Can you do that? Sa Monday, you just send in my messenger. Then next meeting, we'll have a quiz before before the lecture. Okay? This afternoon, at what time was that? Ang 2 o'clock ba? Ang ano nyo karon ang lab? PM. So, we'll see you again at 2 p.m. Okay?
Miss,
Yes?
excuse me, miss. Pwede ka pa nga yun, miss. Ano ganit? Ng coverage, miss, para sa quiz, miss.
Ang naging lecture ta. Plus this one, kaya will be also sending the PDF file in a while. Okay? Damo na how. So, tanan nga na Wednesday. Is it okay, Wednesday? So again, what was the other question, Gani?
Ang akong question, Miss, ang coverage, Miss, ang quiz.
Okay, sige, for a while. Um, short quiz ng 20 questions. Ang first, di ba, introduction to Analchem. Then we have the first part of the basic tools and operation. Then the second part, today's lecture. So you have 3? Yes. Okay.
Okay, Miss. Thank you, Miss.
Bye. See you later. Bye.
Thank you, Miss.
Thanks, Miss. Bye.